Hello and welcome to another session on database and SQL basics. In this session, we are going to look at a clustered index. How does it work and what are the aspects of a clustered index and what helps a clustered index improve the performance of a query that you are performing on a table. So let's jump right into the topic. So consider a scenario where you have to find a particular topic in a book. So how do you go about finding that particular topic in the book? One way to find that is to go through each page, which would take a ridiculous amount of time to actually locate the exact page on which the topic is available. The second option that you have is to use an index. So every book has an index, so you go to that index and you find the corresponding page on which the data is available regarding your search. So similarly, in our database, in a particular table, if you have to find a particular row, instead of scanning the complete table in which the data is available, you will seek the information if at all if the index is available. There are many types of indexes. One of the key type of indexes that we are going to discuss today are the clustered index. So let's go ahead and see on a particular example how adding a clustered index on a table improves its performance and also helps you to actually search faster in using your select query. Here in my sample test database, I have two tables, product inventory and product test. These two tables are same in size, same in structure, they have the same set of data. The reason I have two tables is to actually work on one particular table and show you how it performs with regard to the other table. Now initially both tables are same, they do not have any indexes, they do not have any keys defined on the top of them. So let me just go ahead and search for a particular table. So let me take this table, product inventory. So I will take this product inventory table, I will do a search where product key equals to 173 and date key equals to 20101228. Now let me use a very specific query that will give me some statistical information. The query is set statistics IO on. Okay, and let me also actually include the actual execution plan which can be found in a SQL Server Management Studio right next to your include live query statistics and also the IntelliSense enabled flag. So by default it would be available there. So if I take the same query and also run it on test, since the data is same, you should not notice much of a difference between the execution of these two queries. So when I execute this, you can see there are two rows. So tentatively, since both tables are almost same, you can see that approximately around 3840 plus page reads have occurred on the table, logical reads have occurred on the table to obtain just one single row. And if you look at the execution plan, it has done a complete table scan and you can see the amount of stress that has fallen onto the system. The complete cost on that particular table is primarily allocated towards the predicate searching, where you can see the predicate part of this highlighted portion which says that the product key is equal to 173 and the date key is equal to 20101228. Now in my test table, just for sanity's sake, let me just go ahead and create a clustered index. Here my search criteria on this table has always been product key and date key. These are the two key columns, and these together form a compound key that would be used for searching the table. So I'll go ahead and create a new index. I'll call it as a clustered index. Now usually the naming convention, we use something of this sorts, CIX. You can give the table name, product inventory. Okay, so and then you add the columns. I will select product key and date key and click OK and click OK. So it created a clustered index. Now just remember this, it has performed a table scan earlier, and the product inventory test table has done around 3846 page reads. Now let's go ahead and execute the same query, one set of queries once again. So when I do this, now you can see the second query has run much faster. So let me look what is happening. So the earlier query, which does not have any index, has run the 3847 logical page reads, which is significantly the greater number of reads as compared to the logical reads performed by the product inventory test table select query, where the number of logical reads is just 3. And even if you go to the execution plan, the earlier query, since it did not have any index, it did a complete table scan. But if you see here, this cost around 96%, around 0.041 seconds is the total estimated amount of time that it took to actually execute this query. But if you look at this particular query, though the cost is 100%, you can see the total execution time is almost 0.000 seconds. So almost negligible amount of time, even in the millisecond category. So it didn't even take 1 millisecond to actually return me the result set. And even if you look at this, now it is no longer performing what you call as predicate. Predicate is nothing but your where criteria, where you're filtering the data that I've mentioned earlier. So here it does not do a simple predicate, it does a seek predicate. Remember one thing, in your queries, if you're seeing predicates, that implies that somewhere the index is not being utilized to search for that particular data. But if you see seek predicate, then you will see that the performance of the query is much faster. Okay, now if you look at the product inventory table size without the index, if you go to the properties and click storage, you will see the index space is 0.070 MB with 30.055 MB size. And if you go to product inventory test table, you will see a slight increase in the index space. So you can see that 0.180 MB of size is used as an index size. And basically, when you're talking about clustered index, when you create a clustered index, it's an actual ordering of data in that particular order. So if you take cluster index data, the data is actually ordered. So what it does is that from that ordered data, it will pick up the corresponding row and it will give you this. So you can see this batch has a very high portion of consumption of resources, whereas the below one has very less. So this is how an index improves your performance. So please hit the like button if you like this video and if you like this content, and please do subscribe to my channel to learn more about data and also have a clear understanding how data affects us on a day-to-day basis. Thank you so much.